In this part I will show you how to prepare the tent for cloth simulation, create high poly, bake textures, model structural elements and texture everything using Photoshop. First, let's start in Blender. I merge all structural elements of the tent and hide them, since they won't take part in cloth simulation. I also hide the roof, so that only walls remain. Then in edit mode I extrude stripes of faces along some of the edges of the walls. For each extrusion I add a few loop cuts to make sure topology is dense. After that, I remove top and bottom faces. I continue this throughout remaining corners. Such extrusions look quite ugly at this stage, but after the cloth simulation is done, they will add some foldings to the fabric. When all extrusions are finished, I enter the wireframe mode by pressing Shift and Z and select vertices where the fabric is supported by the sticks and ropes. I also select additional vertices on the top edge of the entrance. They will be animated to create folded drapes effect. I make sure to also select vertices on the border of the bottom of the tent, since I don't want the walls to swing inwards once this cloth simulation is in play. Head on to the Properties tab and add a vertex group, rename it to Static and click Assign. All selected vertices are now grouped. Now let's do the same for the roof. Once again, selecting vertices that won't be affected by cloth simulation. These include the ones anchored by the sticks and the ones at the very top of the roof. And as before, assign them to one group. Okay, now let's show the whole tent and choose frame 0 in the timeline. Go to Physics Properties to the right and choose Cloth Modifier. For the roof, change the mass of vertices to 0.7 kg, reduce compression stiffness, increase shearing resistance, lower bending stiffness slightly, add a pin group and turn off the object collisions. The pin group under Shape tab is responsible for excluding the group of vertices from being affected by the forces, such as wind, gravity, force fields, etc. Just make sure that the stiffness is set to 1. Then set the simulation start and end frames and hit bake. Okay, moving on to the walls now. First, switch to object mode and under data properties add 2 shape keys. A shape key is a set of transformation of vertices. Think of it as a pose for all vertices that mesh consists of. After adding shape keys you can edit existing vertices, but you shouldn't add new ones as this will confuse Blender. So now let's go back to edit mode, click on the second shape key named key 1. Back in the 3D view, select one of the vertices above the entrance and assign a cursor to it. You can do that with Shift and S. Show only faces of that entrance by selecting them and hitting Shift and H. Switch to the vertex selection mode, and in the Properties tab under Object Data Vertex Groups, click on the Static group and press Select button underneath. Now all visible vertices that belong to this group are selected. Set Transform Pivot Point to be the 3D cursor and scale vertices down to that cursor. If you have more vertices selected, you can deselect them by pressing C on the keyboard and middle mouse click on the unwanted vertices. Exit editing and animate a shape key 1. For frame 0, the shape key value is 0, and for the frame 40, it is 1. Test traveling in time back and forth between those frames to see if the value changes. Let's set the cloth properties for the walls now. Low compression stiffness, high shear resistance and a vertex mass of 0.8 kg is fine. Remember to also add a pin group under the Shape tab. This time turn on object collisions and set the base plane which tent stands on to be a collision. To do that, just select it in object mode and under Physics tabs choose collision, leaving all default settings unchanged. Click back on the tent walls and under cloth properties hit bake. Since an object has collisions turned on, it might take longer than before. If the cloth overlaps, you can add self-collision, but it will increase the baking time quite a lot. Let's find the prettiest of frames and apply a cloth simulation on it. Sculpting. It is time to subdivide the mesh. Now I can enter sculpting mode to do some sculpting on top of the cloth simulation. For creating those long foldings, a crease brush with low opacity and a lot of smoothing is perfect. To move big chunks of the mesh, I sometimes grab a tool with a very smooth fall-off. Just like in the previous part of this tutorial, fall-off can be changed from smooth to sharp when pulling on the edges. This high poly mesh is going to be used for baking cavity and normal maps later on, so you don't have to worry about how high poly it is. Just don't add Dino Topo, since it will mess up topology of the base mesh, making your life much harder later on. After sculpting is over, let's save the file and begin baking. Preparing mesh for the bake. Remove vertex groups and add 2 shape keys. Having the bottom one selected, enter edit mode and move the roof upwards. To select only roof, select one of its vertices and hit Ctrl and L to select linked all. Now when you exit editing mode, the roof will go back to its original place because the default value of the shape key is 0. Let's crank it up to 1 in the Object Data tab under the Properties, and the roof should now be floating above the walls. Now let's duplicate the mesh and rename it. One of the duplicates is called Tent High Poly and the other one Tent Low Poly. Click on the Low Poly one and in the Edit mode select all faces, go to the top bar and choose Edge Unsubdivide. Repeat this as many times as you want, optimizing mesh more each time but also losing some of the refined geometry. As long as the silhouette of the mesh looks good, it's fine since most of the detail will have been brought back once the texturing is done. Unwrapping. Usually unwrapping is quite tedious and annoying, but with this tent it's actually not so bad. In the edit mode, add seams to edges by pressing Ctrl E and mark as a seam. The idea here is to cut your UVs in a way that after unwrapping, the stretch is reduced as much as possible. Make your seams follow the convex edges of your mesh where the angle is quite strong. Good way of getting good at UV unwrapping is imagining that your model is made of paper that has to unfold back to flat surface. If you were to flatten your model with brute force, it would most likely rip along certain edges. Turn those edges into seams. Then, when seams are ready, press U and unwrap with option Angle Based. Walls are easier to unwrap. The only thing I do here is add some vertical cuts that are spaced evenly to get smaller UV islands. Let's split the view into 3 windows. One for UV coordinates, second for shader graph editor, and the last one for our trusty 3D view. For now, enlarge the shader viewport with Ctrl and spacebar and add a new image texture node. Create a new texture, set the resolution to 4K and generate the type to UV grid. Now make the 3D view bigger and press Z and choose Material Preview. Your mesh should now display uniform checker pattern. There are some seams, but it's irrelevant. What is important is that there is no stretching. Head on to the UV viewport and readjust the UV islands. To optimize space, I'm scaling them, rotating and moving. The bigger the island, the finer the resolution afterwards, so take your time now to get it as tightly packed as possible. When happy with result, export your UV set to a PNG file. Tick the All UVs checkbox, choose 4K size and fill opacity to 0. Export UV layout and Blender will crash. But it happens. Thanks to the new autosave system I can recover my work quickly to get back pretty much where I left off. So back in Blender, in object mode, duplicate the low poly mesh to create a cage, but not for a human slaves. Just a friendly baking cage for your low poly and high poly mesh in the 3D application. Rename the duplicate to tent cage and inflate it outwards. To do that, click Alt S while in edit mode. To get more precision, hold Shift while inflating your mesh. The idea here is to cage low poly and high poly together so that they can create bakes, normal map and cavity map in a clean way. Before I start baking, I turn on the face orientation viewport overlay to see if all faces have their normals facing outwards in all 3 meshes. Then I select a high poly and create a new material for it. Let's rename it to high, and in the shader editor add a geometry node and the color ramp node. Connect the pointiness of the geometry node to a color ramp and color ramp to a base color in the principled BSDF. Set the color ramp to values 0.4 and 0.6. Then in the outliner window, select the high poly, then low poly with Ctrl, not Shift, and in shader graph for a low poly mesh, disconnect the grid texture from the base color. Click on the grid texture to activate it, and now we're ready to bake. To replace a grid with a normal map, go to the render properties on the side Properties tab and switch the render engine to Cycles, GPU or Compute. Then scroll down under the Bake section and choose Normal, Tangent, X, Y and Z, all positive. Check the Selected to Active, turn on the cage and choose Tent_cage from the drop-down menu. Save the Bake normal map and with the same selection as before, change baking properties to generate a cavity map. All you have to do is switch the normal to diffuse with just a color. Other parameters stay basically the same. Hit bake and save cavity map as a PNG. Stage 8. Replacing placeholders. Okay, it's time to create dollies, beams, sticks, ropes and posts. First, let's start with a column. Just like before, add a cube and rescale it. Then add bevel to all of its edges to get more realistic result. After the column is shaped, add loops of seams at the top and bottom as well as one in between, connecting them. Before unwrapping, apply object scale and rotation so that unwrapping has no stretching. Hit U and unwrap and change unwrapping type to conformal. Conformal deals better with long faces. Now in the side view, copy one of the sticks of the tent and align it with word cording. Adding loop cuts at the top and bottom allows you to change its shape in a more controlled way. You can merge loops of vertices on the ends of the stick using Alt and M, merge at center. Now let's repeat the same cycle for the main post. Just like earlier, I add some loop cuts at the top and bottom and merge some of them to get pointed ending. For both cylindrical shapes, I add a single seam along their length. Moving on to the planks, they're also cubes and their edges are also beveled. Nothing complex here, so moving on. For rope, I use simple cylinder with only 5 sides and many loop cuts in the middle. It has 3 seams, 2 at the ends of the rope and 1 running in between them. Moving on to the final piece of geometry, a dolly. It also starts with a simple cube. In edit mode, bottom vertices of this cube are beveled with a vertex bevel. Ctrl, Shift and B, and amount of segments is adjusted by the scroll wheel. To get better result, you can choose to bevel by the percentage and pick 50%. This, however, will cause some vertices to overlap. So once the bevel is accepted, you have to select all vertices with A key and merge them by distance with Alt and M. Now in the side view, you can add a horizontal loop cut by selecting everything and hitting B to bisect. Previous bevel created some n-gons, so let's fix that by connecting adjacent vertices with J. Do that for all sides to keep the little mesh symmetrical. Now in the side view you can start reshaping it so it resembles a dolly. I position vertices with E to extrude, S to scale and G to move, so it looks like on my sketch. I encourage you to make a sketch before modeling a dolly, since dollies are quite important for the final look of the tent. Once the dolly is set to smooth shading in object mode, it will become very ugly since it lost its all sharp edges. Go to Object Data Properties and turn on the Auto Smooth option to get the edges back. It's a temporary solution, since later on I will add so-called sharp edges manually, and the Auto Smooth threshold value will be cranked up all the way to 180 degrees. While modeling a dolly, don't limit yourself only to one view. Switch to 3D perspective view as well as other side views to see how it presents itself in 3D. Before unwrapping, add seams to this mesh, keeping in mind the folded paper analogy. Once seams are in place, hit U to unwrap all elements: dolly, planks, beam, stick, posts and rope. You can also add a carpet if you want. In the UV editor you can visualize stretching of your polygons by pressing N and navigating to sidebar, view, overlays, stretching and changing the type to angle. It's a crucial feature, so I don't know why it's so hidden. Maybe in the future updates of Blender it will be just a single button on top of the bar, who knows. Since there is some stretching on a dolly, I add more edges and extend seams to unfold mesh better. In the UV editor, select all islands and click UV Average Island Scale. This way, texture resolution will be even across all parts. Rearrange and rescale the UVs, so that they fill up the space nicely. For rope, planks and a beam, make sure that they are placed in a way that will allow you to tile textures later on. Take your time at this stage. It is important to get UVs right. It will make your life much easier later on when you have to texture them. When UV mapping is completed, you can edit meshes slightly by adding more loop cuts and reshaping them so everything looks more realistically. After modeling is done, separate everything by elements and adjust their pivot points so it's easier to transform them. Finally, meshes are ready to replace placeholders in our scene. Just duplicate them and start replacing meshes one by one, keeping in mind not to stretch them too much, unless you're stretching planks, beams and ropes along their longer side, because the texture for those parts will be vertically tileable. Replacement process is fairly straightforward, so I will skip it and move to the rope work. The rope curves, which are placeholders, are Bezier curves with relatively high resolution. Separate a segment of rope from the rest and align a 3D cursor to the end of this rope. Then set origin point to that cursor and bring the pentagonal rope replacement to the same position by pressing Shift and S and choosing Align to Cursor. Then with straight rope selected, go to modifiers and choose Curve modifier, which I have to admit is my favorite. In the target slot, pick the Bezier curve and choose Correct Deformation Axis. You can then scale rope along the curve so that it reaches from the top of the stick all the way to the anchoring peg. When the rope is finished, you can turn the placeholder rope thin again by removing its depth. It's actually better to remove the depth of all ropes firstly, so that you don't have to do it for each segment after you separated them. Like this, you can replace all ropes, and now I'm going to talk about texturing. Let's move to Photoshop. Open up Photoshop, GIMP or Krita and load the UVs of the structural elements. 2K resolution should be good enough. trace selection over individual areas of the map and fill them with different textures on separate layers. You will need 3 different wood types and a piece of metal. I'm using smooth and plain wood for the planks, more rough in the middle, it will be columns and beams, and the most detailed and rough for the spikes and posts. I adjust their color using match color feature and hue and saturation adjustment. I'm adding some paint decals that I have found on the website cgtextures.com. Using mask, I blend them together nicely, then I replace them with a color. It will be a cool texture variation. Now let's create a new layer above those textures and change its blending type to linear dodge add and start painting highlights of the cavities. This is how it looks 12 times faster than real time. Don't forget to add some highlights for the metallic parts. If you don't want to spend time drawing those highlights manually, you can always bake a cavity map like we did before with the fabric texture. Let's make a rope now. It is done in a separate file that has exact dimensions of a rope UV islands. The trick here is to create a pattern that will be seamlessly tileable. For that, I draw diagonal lines and then make a small gradient in between them. I duplicate this gradient along the length of the rope with equal spacing. Then I use offset and patch tools to smooth it out and finally copy it into a previous file where I position it very carefully. It has to match the UVs of a rope perfectly. I turn its blending mode to multiply and then it's ready. Now let's make sure that the diffuse map is tileable. Merge the bottom texture layers and offset them by 50%. There is an ugly seam in the middle now, which can be removed using patch tool. When finished, offset the texture back. When diffuse is ready, create a roughness texture by desaturating diffuse map, inverting it and using levels. This can be done individually for rope, wood and metallic parts. Save diffuse, roughness and simplified diffuse without highlights. Load this simplified version into a free program njob. In njob, set the normal map settings to be X+, Y+, and Z+, and under filter, generate a height map and then normal map based on this height map. Even though I am vegetarian, I use a crispy bacon preset, just because it looks the best. Save the normal map and let us start texturing the tent. Load cavity map, normal map and UVs into a new 4K resolution Photoshop file. Since they have some visual glitches, smooth them out with a smudge brush. Next, based on fixed normal map, bake the ambient occlusion. Let's use free XNormal program to do it. Inside XNormal, navigate to Tools and choose Normal to Cavity, turn on the luminance and set normals to X, Y and Z with positive values. Right-click on the empty square on the right and click Generate. Save the ambient occlusion and cast it into the Photoshop. Inside Photoshop, stack layers to create a simple base color for the tent. On the bottom, I place a single color. Above it, there is a cavity map with overlay blending and another one with a multiply blending. Going up, there is an ambient occlusion, which we just generated with multiply blending as well. Let's adjust the ambient occlusion from XNormal by adding levels on top of it. Higher in the layer stack, there are some gradients. Darker on the bottom parts of walls and roof, and brighter on the top edges. Finally, there is something I call a dirt layer. It contains a simple fabric pattern and layer with stains. Their blending is set to overlay. Save the base diffuse texture and bring it to Blender where you can start painting on it. Back in Blender, switch to texture painting mode and split the screen further to see the shader graph viewport. Apply your diffuse to base color slot in the BSDF shader. Paint directly on your tent. Here, however, I paint on black color because I have lost my tent. Some of you are probably wondering how on earth one can lose something as big as tent. Well, answer is that I'm an artist and I can do stuff like that. It comes with a job. Back to tutorial. I paint a simple pattern on top of a black tent, keeping lines fast and quite rough. In my workflow, I trace over and fix all the lines inside Photoshop later on, so I don't have to worry about their quality in Blender. I just make sure that they look relatively well, knowing that I can fix small issues later in Photoshop. Then bring them in their 2.0 version back to Blender and adjust them slightly. This back and forth process takes some time, but it is worth the final result. Final result looks like this. Base layer is just a color. Then we have cavities and ambient occlusion. Next there are gradients. Above them there is a properly drawn pattern. On the layer below the black pattern, however, there are simple color masks. Red, green and golden. I also create 2 more presets just by changing colors and then merging everything to a single layer by pressing Ctrl, Shift, Alt and E. Since we already have a normal map and a diffuse map, and you know how to create a roughness map, since we already did it for structural elements, here is where the tutorial ends. Thank you for watching. For more cool stuff like that, check my website.